do the true through false here. Had to switch up. I was trying to record it with my phone, and it actually having the same problems that I did the other day, where like the file was too large and it wouldn't upload to my Camtasia. So therefore, I can't actually record the audio with my phone. I'm going to use this microphone, just right there in the picture there, but the sound should be good. All right, so man, true or false are so tricky. So let's see if this is the case. Could you just split those up? It looks like algebraically things should be fine. However, notice what happens when I do 2x minus 8 there at the top. Okay, what'll happen is, since they have a common denominator, I can't now, the limit as x goes to 4 should follow me here. But notice what happens here. I'm going to have 2 times x minus 4. So it looks like x minus 4 actually cancels out. Okay, they do not cancel out here and here. This would be an asymptote. That would be an asymptote. Okay, so that's not going to work. In fact, that's going to lead us right to this guy, and how that does not work. Okay, both of these are not going to work. So that's why this guy is a false, and so is this guy, because if he goes to infinity, you know, you could say as, okay, these guys do not equal 0, even though this guy goes to infinity and this guy goes to infinity as well. If I'm going, I think you have to square these guys though. Okay, but either way, they both go to infinity, and so therefore, you know, they're not the same. So how can they equal 0? So this guy's a false too. All right, now over here though, can we get this guy? Do they equal each other? So here I would plug in a 1, and then I would get like 1 plus, that's 7, that's 0, and then 1, I'd get a 0 over 0, okay, on this side. But over here though, this is going to be different. If I factored this guy, and I got a x plus 7, and then an x minus 1 on the top, and then in the denominator here I would have an x plus 6, and then an x minus 1. You can see that the 1 also cancels out. So therefore, this guy is, as we approach 1, we're actually going to equal 8 over 7. This guy would give us a 0 over 0. Okay, and so that's why this guy is false. All right. Now this guy is true. Now this is true because this denominator is not factorable. Okay, because it's not factorable, there's nothing crossing out. These guys are false because this guy's false and this guy's false because they actually do cancel out. So this guy will work. This is actually true. So it just there's no rule of thumb that you should follow. You just have to see if it works. Okay, because sometimes this is true. Okay, and sometimes it's not. It all depends, because remember, those rules apply, but you can't get that. Okay, that denominator can't equal 0. That's when things get messy. Okay, so yes, in fact, this statement right here is why this guy is actually true. Okay, this guy is true because if f of x is 2 and this guy is 0, then you cannot have g of x equaling 0 in the denominator, so it does not exist. What about this one? This guy is 0 and that guy is 0. Now, what can happen though is something like this. If we plugged it in and got a 0 over 0, if we cancel them the right way, if they factor, you would actually have a whole instead of you'd have a whole instead of an asymptote. So this is actually false. So these guys are deceptively similar, okay? But here, nothing canceled out, so it does not exist. These guys could cancel out, so therefore it would not necessarily be true. 14, if this exists as the limit of this product of two functions, let me just close that for a second. If the product of these two functions exist, okay, then the limit, I should just be able to plug it in. And what if there's holes? If there are holes there at f of 6, then this might be undefined, and maybe that is undefined. But it doesn't mean the limit can't exist. So, again, this is actually false because you can't just always plug things in, as we know. But we're just trying to look for situations here where you're trying to find counterexamples. Okay. Now, if p is a polynomial, then all is well, because polynomials are continuous, they're smooth, there are no holes. You know, it's these rational functions that really mess up the game, okay? But polynomials, it's a straight shot. These guys are beautiful. So this guy is actually going to be true because, man, you just straight up substitution every time. It's great. Okay, we talked about this guy, how he's related to here. 17, this one, this one drove me crazy. I think this is kind of unfair here. If the line x equals 1 is a vertical asymptote, okay, of y equals f of x, then f is not defined at 1. Okay, well, what if it's a piecewise function? Okay, well, where'd my picture go? I don't think you need to see me there, sorry. But I don't know if that helps or not, but I will, come on, man. There you are. I don't know if this helps or not to see. I like to see a face when, you know, talking to me. So so yeah. So anyways, couldn't we make an f of x function where it's like 1 over x minus 1, okay? And then we have asymptotes, but then couldn't we say, though, by the way, at x equals 1, couldn't we give it? Okay, that is a counterexample where you could have, you know, this guy right here, just like that. But then we could do a piecewise function and say, oh, by the way, it equals 5 at 1. We could create that to make it work. And so, believe it or not, this guy is false because we can mess around with f of x to make it do what we want. And so, having it not defined is a little, we could do that, okay? And I think this is a really tricky question. Okay, now 18, I mean, the IVT, right? IVT says this guy should be absolutely true, right? If f of 1 is positive, okay, if f of 1 is positive and f of 3 is negative, then there exists a number c, right, in between, such that it equals 0, right? Now, nobody said anything about it being continuous. It should have said if f is continuous or f is continuous. Okay, we could have a function that looks like this. Okay, and we are not guaranteed anything because it did not say continuity. That's why that first condition is so important. So this guy is a false. Okay, that's another tricky one. All right, this one right here. If f is continuous at 5 and f of 5 equals 2 and f of 4 equals 3, then the limit of this guy equals, let's see, 2, that would be 4, 6, well, no, I'm sorry, 4, 16 minus 11. Wait, what is that? Okay, if f is continuous at 5 and f of 5 equals 2. And f of 4 equals 3. Then the limit. Oh, okay. If the limit at x equals 5 is 2, okay, and f of 4 is 3, okay, so let's say it passes through here, then the limit, oh yeah, okay, because this is a continuous function here inside a continuous function at that moment where it is continuous, so it would have to equal 2. Okay. Right? Yeah. All right, 20. All right, so absolute value functions. These guys, remember, they're always going to look like this most of the time. Okay, they might shift over a little bit here or there, but what we've got here is when we go towards 0, we're always going to, we can't throw in a 0, okay, but we're always going to have that step. If they canceled out, it would be 1, but if we're coming from the left, it'll be -1. If it comes from the right, it'll be +1. And so the general limit, though, does not exist, so this is a false. Okay, if I said if it's going to 0 from the left, it would be negative. If it's going from the right, it would be positive. All right, so this guy right here is actually connected to this guy. If the limit of f of x as x approaches c is L, then when I plug in c, shouldn't I get L? And the answer is no, of course not, because we could have a hole. Okay, so this guy, f of c, does not exist, okay, but the limit does exist. Okay, so this guy is actually a false. And kind of along the same lines, if f is undefined at x equals c, then the limit of f of x as x approaches c does not exist. If it is undefined, okay, just because it is undefined does not mean that the limit does not exist. And so these guys are kind of connected to each other like that, because we can draw the same picture to show that this is not true. Okay. All right. Super tricky. I would say if you probably said that half of those were true, man, it's just like you got to read them like a lawyer. Okay. This is why people who study mathematics do really well on the LSAT, because every prepositional phrase is extremely important.